Okay, so can y'all hear me? So I'm gonna start by showing you guys how to cut something on a laser cutter. I'm not gonna go super in depth with this just because you can't see everything that I'm going to be doing, but I just kind of wanted to go through the process so you could see start and finish how that happens. And what I have right here is an Illustrator file that is a bunch of little pieces and parts. So this actually ends up making a cube, and these are all tab fit sections that will fit together. So this was designed to be cut on a CNC router and made much larger out of something like plywood, but I've scaled it up and down to different material thicknesses, and I'm going to cut it out of cardboard today that's about a 1/4 inch thick. So I've got this pulled into Illustrator, and I have to make sure that the stroke weight is thin enough. So right now, if I deselect it, you can see that it's barely visible. It has to be super thin for the laser cutter to interpret it as a cutting line. So I've selected everything and changed the stroke weight to 0.001 inches. And that's kind of a universal, actually this was 0.001 points, size just for laser cutting. And it just kind of disappears on the screen. But in order to send this to the machine, all I have to do is go to File, Print. And that's the great thing about a laser cutter is you're just sending your print job to it. You don't have to know anything about CAM software or programming tool paths or anything like that. You can send it a Word document if you want to, and that will just engrave onto whatever material you put in there. If you want to cut, you have to send the job from a program like Illustrator that works natively with vector graphics. So I've got this laid out, and I just click print, and then that brings it into the Epilogue job manager. And this kind of shows you an overview of what's actually in the laser bed. So the nice thing about this is this laser cutter has cameras in it that give you an overall view. It also has a view of what's actually at the laser head, and it will move and update live as you're cutting. So this is the zoomed in view of that laser head. And you can see these parts already cut in this sheet. I'm just gonna cut it again. So when I first sent this to the job manager, it ended up over here. So I actually need to drag it over and put it onto the piece of material that I'm gonna cut. And the nice thing is I've got a live camera view of what's in there. So I know I'm not gonna end up cutting in an area that I've already done. And you can kind of see like the outlines of where it's gonna be. So once I've got that in there, I just need to set my speed, power, and frequency, the 3 values that define how this cuts. And I did testing of this earlier, so oh, you're still on the Illustrator file. Let me see. How do I switch? Okay, so y'all can see that. That's the overhead view inside the laser cutter. And this is from the camera. There's 2 cameras actually that make a composite image looking straight down. And then there's a 3rd camera right on the laser head. And I'll show you that in a second when we start cutting. So I've been able to drag around my print job and just position it on the material just visually. I don't even need to take measurements. I can just kind of line it up however I see fit on the screen. And I'm going to come over and edit these settings over here for cutting through the cardboard. And I believe I was using this before, but we'll see if it works. It's not a big deal if it doesn't. I've already cut this out to show you what it is in the end. The laser cutter has to be focused. The laser beam is kind of like a cone shape, and it tapers down to a single point and then digresses away. So if you're outside of that focal range, you'll start burning the material, you can start a fire. All of those things have to be checked before you go in and start cutting. So I've got this set up ready to go. My runtime is going to be about 3 minutes and 40 seconds. And I click print to send this over. Now I can switch over to the camera that's on the laser head. So this is looking straight down at the material. And I even have the ability to move the laser head around with a joystick that's on the machine. But that's really just more for positioning if you wanted to line something up, doing it that way. This job already has all that information in it. So all I have to do is go over to the machine, select the job from the touchscreen list, and then click play. I do have the exhaust turned on already, and you might be able to hear that noise in the background, but this will make it so all the fumes, everything gets exhausted out of the building. So I'm just gonna click play. It's gonna go over to the starting point and autofocus. And it's gonna be a little laggy on that screen. If you look at my camera feed from my phone, you can look at an overhead view, but you still can't see much because it can't get that close to it. So this is just using the CO2 laser tube. This machine actually has 2 lasers in it. The CO2 can cut flammable material like this, and the fiber can etch away at the surface of metals. So both have their uses. The metal part is interesting because you can mark metal pieces that we could cut with the water jet or just cut by hand. The CO2 will be able to cut thicker materials such as acrylic sheet, which is going to be like the main use that we have in here, but also woods. Cardboard's okay. I'm just using cardboard because I'm overloaded with it right now. I just spend half of my day breaking down cardboard boxes, it seems like. But this cardboard is corrugated, so it's got this air gap in the middle of it, which can cause fires sometimes. Embers can get stuck in there. And all of these pieces that I'm cutting are actually going to fit together, if you look at my phone screen, into a cube that looks like this. So it's 3 pieces that are different, and they all fit together in a somewhat complicated way. I spent about 20 minutes doing this earlier, trying to remember how to put this together. I designed this joinery back in 2012, I believe, mostly as a way to show off how you can make something very strong out of very weak material. Because this is corrugated cardboard, it doesn't stick together very well, but I could put like a little bit of super glue or something like that on there. I also cut it out of some very thin plywood as well, and made it much smaller, and it fit together a little bit better because of that. So it's almost done. It's got a few more pieces to cut out. And you might be able to see the smoke in there, maybe not, just because of the resolution. But that does happen as you're cutting. That's why we have exhaust. You have to have exhaust for something like this, because we're vaporizing that material. So now we are done. And can we switch? I guess that did switch, right? So now we're on my phone screen. Right, everybody can see that. So I'm gonna open up the laser cutter. And you can see all of these pieces that are cut out that are still sitting in here. And they can basically just pop out. Sometimes it gets stuck with cardboard just because it doesn't want to drop out, just because it's inconsistent as you're cutting. I'm going to go ahead and turn the machine off so we don't have to listen to it, because the fans in it make a lot of noise. And I'm not going to bore you with putting this together because it will probably take me about 20 minutes. But I can give you a closer view of this one that I put together earlier. And this is strong enough that I could most likely stand on top of it, even though it's made out of pretty weak cardboard. And then here's that wooden version that I made earlier as well. So any questions on laser cutting? And that was just kind of a quick preview of how that works. And if you think of something later, just let me know. I'm going to move on to the vacuum former. Yes, the laser works on acrylic. It's one of the best materials to cut with a laser cutter because you get very clean edges. It'll actually polish the edge as you cut. And you can engrave on it. It looks kind of like frosted, so you sanded it almost. The laser cutter will not cost anything to use. You will have to acquire your own material, or you can buy material in the MakerSpace. And if you think of another question later on, I'm happy to answer it. I'll now move over to the vacuum former. So if you were in here earlier for the tour, you probably saw this. This is the vacuum former, and it works by heating up sheets of plastic and then forming it with a vacuum over the top of some sort of mold. And I left this car in here just to show you of what the capabilities are, but I'm gonna go ahead and open this up and remove the car shell, and you can see it's just thin plastic. I believe this is actually PVC material, which you cannot cut on the laser cutter because it creates chlorine gas. Anything with a vinyl in it is bad to vaporize, but it does stretch and form very well because it's a thermoplastic, meaning it bends with heat. So if you've ever seen a blister pack, something like this with these wrenches in it, that's how it was made. It was heated and then formed over that shape. I actually did this yesterday with some 3D printed pieces as a test. And because these had undercuts, they actually got stuck into the sheet. And the only way I can get them out is to cut the plastic away. So I might do that later, but that was really just a test. I actually prepared a 3D printed piece myself that I printed overnight last night. That just says Alkek 1. And I've zip tied it to this mesh screen that's in here. And if you look closely, I'm gonna line this up, there's that hole right there, and that's where the vacuum comes from. So air has to be able to come from below this. That's why you have this mesh screen in here. And I zip tied it down, hopefully, so it doesn't get encased in the sheet of plastic. So after I've got that in there, I move this handle that's on the side and lower that down. Then load a sheet of plastic and make sure it sits all the way around on that seal. There are different reducing windows to use smaller sheets, so you don't have to use a whole sheet. I'm just using some sample material that came with this, and it just makes it a little bit easier. And then I clamp this retaining frame back down, and it's basically ready to go. The interface on this is all through this little touch screen. This button right there turns on the heater. Then just drag the heater over top, and it's gonna beep. I guess warning you that you've activated the heater and it's hot. And then I can go into this menu and edit different manual settings about it. It's all symbol based, so we'll have a guide that shows you like what each one of these symbols mean. If you look closely, you can see that there's a counter on the heater symbol. So that's how long it's been heating, so you can keep track of it. That next one to that is actually to inflate the plastic. You can blow air below it to blow it up like a balloon. So when you bring your mold up, it doesn't hit the plastic prematurely. The next one is a vacuum symbol. That's to suck it down. The one next to that is a cooling blower, which is mounted up overhead. That's to instantly cool the plastic down. The ones below are for like custom settings. This one is actually an automatic level adjustment. It will pulse air below the plastic sheet if it starts to sag to keep it from hitting your mold. And then that last one in the corner is to release the plastic from your mold. It'll shoot a jet of air to just kind of pop it off. Some of those aren't necessary. It's just kind of different ways to deal with different problems related to this process. The timing for how long you leave the heater on, it's really dependent on how thick the material is, how big the mold is, how tall it is. It's kind of guess and check in the beginning. We'll eventually have a database, like kind of a list that shows you what works, what doesn't. But there's not much of a procedure to it. You can always check. So you can roll this out of the way, and I can see that that plastic sheet is sagging. You might not be able to tell from the video, but it does heat up pretty quick, and it doesn't take much because this is maybe 2 millimeter thick plastic. So I'm gonna go ahead and roll the heater out of the way, and I'm gonna inflate this just a little bit. And I'm just tapping that button. And actually, I might have a leak somewhere. Oh, I think it needs a little more heat. And you might be able to hear that sound in the background. That's the air compressor. It just kicked on because I used some compressed air. So the nice thing about this machine is it's fully manual. You don't have to have it connected to a computer. It's not really a digital fabrication piece of equipment, but you can make molds using some of the other processes that we have in here. And it's a very quick way to make a shell of something. You could make a mask using this. And that's one of the most popular uses for something like this. But it's really kind of up to whoever the user is. I'm going to end up using it to make holders for wrenches like this, but most likely out of a formable foam, something like that. So let me check on this again. So that looks good. I'm going to go ahead and pull my mold up into it. And then I'm going to vacuum it down. And it didn't really get all of it because of how sharp the edges are on this. And then I can turn on the cooling blower, blowing air over top of it. And there you can see it kind of formed to that. It really just, I probably need thinner plastic to be able to get to that, but it kind of looks like a ghosted Alkek one. And you can see there's probably just not enough space in between each one of those letters. I could probably make it larger and it would work a little bit better, but you can kind of get the idea of how that's useful. So I'm just going to go ahead and drop this back down, turned off the heater. And let's see, we are at 256. So I guess I can answer any questions related to that. You guys have any?
There was a question in there about, did you explain how you made your Alkek 1 mold, the one that's in the machine?
Hold on, I can barely hear you. Okay.
Can you hear okay now?
Yeah.
Okay, Donna asked how you made the Alkek 1 mold in the machine.
So that was actually 3D printed. So I designed that in Rhino 3D. It's very simple, just using a text shape. And then I 3D printed it on the Ultimaker S5 last night. It took maybe 2 hours to print.
Any other questions for this session?
If you want, if we got like a couple minutes left, I can very quickly show you what the 3D scanner looks like. Probably not enough time to actually scan with it, but maybe. So here it is. And this is a handheld 3D scanner. And it uses structured light to actually scan with. So it's all self-contained. The data can be stored in this in a micro SD card. And it can also wirelessly stream that data to another computer, which is super useful. You're not tethered to a cable. You can be if you want, if you really need that hardwired connection, but it's got a built-in battery. It's got everything in it. It has a very fast processor. so it can process this data live. And so that was it starting up. Now I've pressed the scan button to get it to start scanning. And now it's ready to scan. So I can press the scan button. And now I'm scanning this hand truck. And this is probably not the easiest thing to scan because there's a lot of hidden areas, but it can scan basically just by seeing whatever it can visually see, it gets scanned in. So I'll just stop that real quick. And then you can see what I actually scanned in here. And I can do this with one hand, but you can actually, this is a touch screen, so you can interact with it pretty easily. So I can spin the model around. Any red area is an area that did not get very good data, but you can see it does full color texture. But yeah, that's basically it.
Trisha's asking, can you scan the inside of a room?
Yes, it would probably take you a while, but you could do that.
She says woohoo. I have a question too. Are we going to be able to reserve time on these machines, or how is that going to work?
Yes, most of the equipment has to be checked out first, which means you just come in and check it out. We might hold on to like an ID card or something while you're using the piece of equipment. Everything's going to be a little bit different in how you use it, but everything should be reservable. Some of the stuff that be more like just walk up, maybe the sewing machines or the electronics workstations, those might just be walk up, but things like the laser cutters, the water jet, the 3D scanner, those will all be reservable ahead of time.
Awesome. Any other questions? I think I have a lot of people saying super cool, nice job, it was awesome. That was definitely very cool. Anyone else? Anything else? All right. Thank you very much, Noah. That was
You're welcome.
super awesome.
And you can always email Alkek MakerSpace at txstate.edu if you have other questions. I'm happy to answer them. That email is going to end up going to me.
Perfect. Yay. Okay, I'm going to stop the recording.